This is Gail Kovac for Gresham-Barlow School District, Summer School, High School Credit Recovery, Algebra 1B, Learning Target number 11. I can simplify expressions using the product property of exponents. So we're going to have lots and lots and lots of repeated multiplication here. And the way I like to teach is this first tell you to, when in doubt, expand it out. You must remember that an exponent means repeated multiplication. This is not m times 2. That is m to the power of 2, meaning m multiplied to itself 2 times. In other words, m times m. This is m multiplied to itself 3 times, m times m times m. Now, that's a lot of m's. Let's actually multiply it all out, and then we'll condense it back into one nice tidy package. All right. So this part is 2 times m times m. That's 2 and m squared. Now I've got to multiply that. 2 times m times m times m. All of that's being multiplied together. I expanded it out. I rewrote that multiplication as that exponent as repeated multiplication. So now let's see some things that have the same base that we can condense back together. All right, I see 2 2's. There's 2 of them here. That is 2 times 2, which gets you 4. Now I see lots of m's. I see 2 of them here, and I see 3 more of them here. Altogether, that is 5 m's. So I could write m, 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 m. I could write 5 of them, or I could just use as a shortcut an exponent of 5 to show that there would be 5 m's multiplied together. So that is m to the power of 5. Now, if we didn't want to have to go and multiply and expand all of that out, which once you start getting to really high exponents like m to the power of 10, I don't want to have to actually draw all those out. That takes way too much time. How can we have figured out that this was going to be an exponent of 5 without doing all of this work? Let's see, how do we get a 5? Wait, 2 m's multiplied, then 3 more of them, that's 5 altogether. 2 plus 3 equals 5. So the product property of exponents says that you can just add the exponents when you're multiplying because it shows repeated multiplication. So here's your first answer. Now, the actual numbers that we know, like 2 times 2, you would actually multiply that out by to get you 4. But the variables, you can just add those exponents if they're all being multiplied together. Let's try it for this one right here. All right, it looks like the only number that I know for sure is the 4. And I don't see any more there, so we're going to have just a 4. All right, ooh, looks like I've got 2 different variables here. I've got v's and I've got u's. All right. Let's see how many v's I've got all together. Well, I've got 3 of them here, and oh, how many do I have here? Oh, there's an invisible exponent of 1 for this v. There's 1 more here. So 3 v's times another v. How many v's would that be all together? 3 plus 1, that would be 4 v's. All right, I've got one more that I've got to deal with here. I've got some u's, and I think that's my only group of u's. I don't have any more to combine with, so that would just be 2 u's that I'm multiplying. Now, I wonder if I expanded all this out, would I get that same thing that I was just doing? Let's see. I want to double check. All right, so I've got the 4. That's times v times v times v, and then times 1 more v, and times u times u. Let's see, did I do this right? I've got the 4, and I've got 4 v's, nice, and I've got 2 u's. Yeah, I think that worked. So for the product property of exponents, you can expand it all out if you're not sure. That's why I say when in doubt, expand it out. And then, oh, I see what I need to do. Or for multiplying straight across like this, you can just start adding the exponents of the not like terms, but like variables here, and then just see how many you're multiplying all together.